Hey guys, it's Simon, and this is another video about the Fleks entity component system written in Kotlin, which is now almost getting 1 year because the first release I checked it was actually in November last year. So soon it's about 1 year where we have this component library and entity component system. And I'm currently working on a version 2.0 because, as you might know and heard in other videos, there are currently always two versions of this library. There's the JVM, so the Java virtual machine version, and also the Kotlin multi-platform version. And both of them are slightly different, and I always wanted to combine them, but I never had the time and also was not sure how to combine them. And now, since a couple of weeks, I'm working on the version 2.0, so it's a bigger release for this library, where I then actually combine those two versions. So the JVM and KMP version, they will be combined into a single one. There's currently a pull request open. On GitHub, there's almost everything is done, so I still need to update the Wikipedia pages with the new API of the version 2.0. There's a longer discussion with a couple of people. This guy was helping a lot with the Kotlin multi-platform version, the first one, and I always use him as a feedback for the Korge, so the Kotlin game engine library games, so that he can give some feedback there as well, how it feels and how everything is working out. And in this video, I want to show you what kind of things are changing, and also maybe get the feedback if you like to tell me which API you prefer, what you think, maybe something that could be improved, or if everything looks good and you are happy with that, and things like that. And for that, I created a little example in Fleks 1.6 version, so currently the latest version of this Fleks library. And that piece of code that we see here, we are going to convert that to the 2.0 API, where there are a couple of changes. So there are, of course, breaking changes in that, but I think it's for the better, because at least I personally, and also the people in the pull request, they prefer the new API, and it's more intuitive. I will elaborate on that, why that is, but first of all, let's go through the example very quickly. So what we have here, we have three components. We have a position component with a vector. We have a sprite component with a path to the file of your sprite, and maybe, for example, a rotation, how it should be rotated. That specific sprite has a so-called component listener, so we can react on when a sprite component gets added to an entity. We could also react on when a sprite gets removed from an entity, but there we don't care, we just refer that to units. And we have a dead component, which, for example, an entity gets when it is dead. And then we have a very simple system, so for example, a position system, which iterates over all entities which have a position component and which do not have a dead component, so we only are interested in entities which are alive. And in that specific system, we want to modify the x and y coordinate of the entity, for example, by adding 1 and 1 to x and y. And if the entity also has a sprite, then for whatever reason, we want to change the rotation to 90 degrees. And there we need these component mappers in the Fleks 1.6 version to access the components very efficiently. And also, as an example, so that you see that the difference then with 2.0, we also get in here a stage, and Fleks, as you might know, it works with the dependency injection pattern actually. And there, so this stage here, we don't define it here, it gets then injected automatically when the so-called world gets created. So this is here below, so this is the main function. There we create a new world, we have that is DSL, so the injectables for our world. There we just want to have a C2D stage from libgdx, so that one automatically gets then injected here in the system, and also here in this component listener. Then we have a component listener, so this is defined in this components block. There we add this component listener, which then also gets created by Fleks and everything gets called correctly. And we also add this position system in there. And we create a small entity, so the entity has a position component. We set the x and y coordinate, and it has a sprite component, and there we set the path. And then, just as a showcase, outside of any system, we want to configure that specific entity, and there we want to remove, for example, the dead component. So it does not have that yet, so this example does not really make sense, but just that we have an example and see that the difference when we convert this code to the Fleks 2.0 code. So first of all, what did I not like in Fleks 1.6, or which people were also a little bit confused? I personally did not have a big problem, but I heard from people that they do not really like this component mapper, so that you always needed these mappers to work with the components. Did not really felt intuitive, because what people prefer, they just want to have an entity, they have the component, and then they want to simply access it. So this component mapper stuff here, I heard from people that they found that confusing and they did not like it a lot. Also, like here outside, so you want to configure the entity, but to configure something, you always needed to retrieve the mapper first to do something then in there if you are outside, for example, of a system. And this was one point, in my opinion, where we improved in this version 2.0. You see that in a moment, but just to explain it, because it's an important concept. So why are the component mappers even needed? I think I mentioned that in one of the videos, but I cannot remember in which one, so I explain it once more. So in general, when you create an entity component system, and here it's a general component system, so it's for any game, you could use that, and usually you have an entity which ideally is basically an ID. It's nothing complex. So for example, in Ashley, in libgdx Ashley entity component system, the entity is actually a class, which also has some additional logic in it, and I think some references to certain things, which is not ideal. So ideally in an entity component system, an entity is simply an ID. And in Fleks, I followed that approach, and the ID is simply an integer. So that is one of the reasons why it's also so fast compared to, for example, Ashley, because working with integers and in the background then with integer arrays to iterate, for example, so over certain entities is a lot faster than working with classes and iterating over certain classes. Then we have components. So for example, in here we have the sprite, we have the position, and we have this that component. And what you want to have, you want to simply add then those things. So for example, you want to add the position component to an entity, you want to maybe add the sprite component to it. And for example, you want to remove a that component, for example, from it. And somehow in the background, of course, the entity component library needs to know what kind of components does an entity have. So for example, when I want to access the position, so for example, I want to write something like this to access the position of my entity, or the sprite component, for example, like that. So if I want to do that, then the entity somehow needs to know what kind of components it has and how can I access that. And since we only have those classes, so the component classes available, one very intuitive approach, I would say, would be that we store, for example, with an entity, we have like a map, doesn't matter what kind of map, that's not important, then maybe a class, so that would be the component class, and then the real instance to that component. Let's say that would be a component class, for example. So with that, when we have an entity, then we would know when we pass in, for example, like this, so the position, then we could look up in this map, okay, do I have the position class in my components map? So let's call that, for example, components of an entity. So if this position class is available in this components map, then I can return the position component. And if it's not part of this map, then this entity simply does not have this component. So that would be, of course, one solution to do that, so that you know what kind of components does an entity has and then how to interact with it. But the map actually is quite slow. So also if you would use a hash map, and you might think, so just hashing or using the hash code function of these classes here and looking that up in the map, that's actually not that fast. It's actually pretty slow. And what entity component systems do there, so Ashley is doing it, also Artemis is doing it. I also saw some other C++ entity component systems are doing it, and also Fleks is doing it. They simply assign unique IDs to a type of component. So the position, sprite, and that component, they have an ID. So let's say, for example, sprite has 0, position has 1, and that, for example, has the ID 2. And with that approach, so if we assign a unique ID per class or per type of component, not per instance, so that is important. So if we have, I don't know, 100 instances of the position component, we don't have 100 IDs, we only have one ID, so like a static ID to the position class. And with that approach, so when we have these IDs, we can actually then convert this approach here, and instead of using a map, we can simply use an array of components, because we know now that every component has a unique ID, which is the index in the array, and then using a lookup with that specific ID in the array, so to check is this index, for example, null or not null, is a lot faster than using this map approach here. And the problem now here comes that in Java, so in the Java virtual machine, for whatever reason, don't ask me why, it is not possible to make inheritance with static members. So also in Kotlin that is not possible. So for example, if we would have a component class, just imagine that, and there would be an ID in that with 0, and then for example we have another class which inherited from that component, then it does not inherit the companion object with the ID. So the static inheritance is unfortunately not possible, and that is the main reason why I introduced this mapper concept. Actually, I took it over, so I saw that Ashley and also Artemis are using a similar approach in their libraries, and the component mapper is nothing else that for a specific component, so for example for position or sprite in here, it internally creates these unique IDs. And then somehow, you don't need to know the details, somehow with the mappers we can then get to an approach with this array-like lookup, which is then a very fast access and also creation, so retrieval and creation of components for an entity. So that is the main reason for these component mappers, and also why we needed that, so to create these unique IDs. But now with Fleks 2.0, that approach has now changed completely. So what I want to do now with you, so that we also see the difference in there, I want to convert now all that code that we have here. I want to convert it to the Fleks 2.0 version. And to do that, we first of all will change the dependency. So I currently have a local snapshot on my computer, so I can already use the 2.0 version. It's not official yet. I hope that I can release it maybe in about 1 or 2 weeks, most likely 2 weeks, because I need to update the Wikipedia page and want to get some final feedback from certain people before I move there. So let's move to the 2.0 version so that we then see the differences, and also let's make that side by side. So here we have the Fleks 1 version, and here we convert it now to the Fleks 2 version, and I will highlight the differences that we need to have there. So as you already see, so there are already some compile issues because certain things are simply no longer available. I will go through it step by step and explain it, but first of all, let's comment out here everything that we don't have any compile issues. And now let's go through that step by step. So position component, this is, in my opinion, I'm not 100% happy with that, but it is what it is. And with the approach that I'm showing now, we actually get a very nice, in my opinion, a very nice API for the rest of the Fleks library. But setting up a component is now unfortunately a little bit more boilerplate than it was before, but luckily with modern IDEs nowadays we can simply use live templates. And for example, I created one which I called Fleks template, so I just typed that, then I want to have, for example, a position component, and that's already it. So our position component here, just to have it consistent with the example on the left, we also have here a vector 2, and this is one advantage here, or one change that we have here. We no longer need no arguments constructor in Fleks 2.0 because components are no longer created via reflection, and this is, in my opinion, the first big advantage of the version 2.0. I completely removed all of the reflection stuff and all the magical stuff that is happening in the background. So now you are really calling, you see that then below when we create the entity, you really create already immediately the component when working with entities, or when you want to create a component for an entity. So this is already the first difference. Before, we always needed a no arguments constructor because the component was created via reflection. To show you that, so that call here, so that one in the background created a new position component via reflection access, and then with a lambda afterwards you could modify the component. So this is how it was done in version 1.6, but now we don't need this reflection part anymore, so we can also leave this, for example, empty, so that we never forget that. Then there is a new class, actually two new classes or interfaces in Fleks. The first one is the component type. So this is an abstract class, as you can see here, and that one is responsible to still create those unique IDs per component. So here again, it's the companion object, because we want the ID statically for the position class and not per instance. And this component type, simply in the background, it increases a counter, and every time you assign or create a new component type, you get back a new unique ID for your component. And the second thing is the component interface, which always has one method, which is the type function or method, and that one needs to return a component type. So that Fleks knows when, for example, we would add, do we still have the example here? No. So when I would add, for example, a position component to an entity, somehow Fleks needs to know what is the ID of that. So it needs to return the component type. So here we don't see that because my live template is not showing that, but the component type or the type function needs to return a component type of the component that we have here. But it's a little bit shorter to write it like that, so that is why I have it like this. So this is now the basic setup of a component, which is unfortunately a little bit more boilerplate stuff, but I don't see another solution, and it's mandatory to retrieve this unique ID per component. There's, however, an advantage with that specific approach that I show now in the next component. So let's make another Fleks component. This one is the sprite component, and also to be consistent, this can of course be a data class, so there is no limitation with that. The sprite has, what does it have? It has this path, and it also has this rotation. So let's also take that over. Okay, and with the sprite, just to give an example, you are no longer limited that you can use a specific component only once. So with Fleks 1.6, it was only possible that you add one component of type sprite to an entity, and if for whatever reason, for example, I don't know, you want to split between a foreground and a background sprite for whatever reason, just as an example, before you would need to create a sprite foreground component and also a sprite background component, because you could not reuse the same component twice, because the component mapper is related or linked just to a class, to the sprite, so you only have one ID for one component. Now, because the type function of a component is actually a function and we can do whatever we want with that, we could theoretically use the same component for different purposes. So just to give you a quick example, so let's say we have, for example, a background sprite and a foreground sprite, just as an example. So what we could now theoretically do, so let's, for example, also say, so if this is a background sprite or not. And here we can now do in the type function, we can of course add any logic, so it doesn't have to be as simple as that, but just returning a type. It can also be more complex. So for example, let's say if it is a background, then we return the background sprite component type here below. And otherwise we return the foreground sprite, and this returns a component type of type sprite. So now I can show that maybe also below, we can reuse this component here, this sprite, but actually have two different purposes and two different IDs. We have a background sprite ID and a foreground sprite ID, but we don't need to copy and paste the entire component. We can simply reuse it. So this is one advantage or one possibility that we have with that specific approach that we have now here. Okay, and finally also let's create this that component, which is again a very simple one. So that is the changes about the components. Again, it's a little bit more boilerplate stuff, but as mentioned, it's mandatory. And now you see that in a moment, the interesting part, we get a better API, in my opinion, and an easier to use library in general. One thing that we don't have here is this component listener. That one I will cover below a little bit when we create the world. Okay, so a system, how does it look like? So it's very similar, so we can, let's just copy and paste the entire code here over. But what we don't have anymore, so first of all, we don't have component mappers. We can completely remove that. That is no longer necessary. Then the annotations. Unfortunately, we cannot use that because at least I could not figure out in a Kotlin multi-platform project how to use annotations in the background. I think it would be possible with the Kotlin reflection library, but that would require a very big dependency. I think it's 2 MB or something, the Kotlin reflection library, if we need that. So what I went for is a simple, again, a DSL functionality or a utility function, let's say, and it's now the argument of the iterating system. So to make it clear, there is a family argument, which is the first one. And you create an iterating system, and there we can now create a family like this. So there's a family function, and in here we can use, for example, an all function, where we say we need components or entities which have a position, and they should not have a dead component. So something like that, and we no longer need then the annotations. So let's quickly import the missing stuff here. Okay, so this is already one change. So annotations are gone. We no longer have them. We need to create the families now like that. Of course, you can remove that, but just to make it clear, there's a family argument for an iterating system, and there you can create families now like that. And here is already the first advantage. We no longer have this class stuff, which I always found a little bit ugly, because now the library in general is mainly working now with these component types because it's only interested in those specific IDs. And since in Kotlin we can have unnamed companion objects like here, so this companion object does not have a name. So to access it, we can simply write the name of the class like here, so position and that. And with that, we can, in my opinion, write a very readable version of this family. So a family that has all components of position and it has none of the dead components. So something like that is, in my opinion, a little bit nicer to read. Then the stage, how to inject that. There is now an inject function that you can use, and with that you could inject the stage still with this dependency injection mechanism of Fleks. But this is also one change. This is no longer mandatory. So if you don't want to use the dependency injection mechanism and you want to pass your arguments directly, then you can also do that. We see that then below, but this is also one thing which I think is maybe a little bit of an improvement. So if you are confused or don't like the dependency injection mechanism, then you don't have to use it. But if you prefer it or if you like it, then you can still use it like that. So we can still inject the arguments, but we need to explicitly write it down because, again, reflection is gone and also the systems are created by you. It's no longer created magically in the background. It's now created by you. We see that again also below. And finally, which is in my opinion now better, is the API that we can achieve here. So now we no longer need these mappers and we can now write something like this. So from our entity, we want to have the position component, and there it's the same code here as below. So we can now write something like this, which is in my opinion more straightforward. So from my entity, I want to get the position and then work on it. Or here there's also a new function available. So this checks if an entity has a sprite, but we can now write something like this. So if the entity has oh, we split it up here. Let's say if it has a foreground sprite, then we want to get that. So from our entity, we want to get the foreground sprite and do this rotation, which is, for example, 90 degrees. So something like that. So in my opinion, this is a little bit more readable and yeah, more intuitive, I hope, for the users, that you work here really with the component classes that you have created above, and you no longer need to work with this mapper. So still in the background, there is something like that available, of course, a little bit simplified, but as a user, you don't need those anymore. So you really just work with your components and you are no longer interested in any mapper. So basically all those mapper definitions, they are gone. You don't need them anymore. The annotations got replaced with this family function that we have now here available. And the dependency injection part, that one is now optional. You can still use it with the inject function, but you don't have to use that, which we see then in a moment. Okay, and the last part. So let's create a new main function. Creating the world did not change at all. So there, yeah, but it changed a little bit, but there is still the injectables block, we have the components block, and we have the systems block. So this structure, this DSL is still the same. For injectables, it's actually completely the same. So there you can still add them like we were able to do that before. For components, there something has now changed because there is now an on-add hook. I explain that in a moment what this is, and an on-remove hook. So before in Fleks, I had this component listener approach. So you could define a component listener for a specific component, assign it, and then this on component added and on component removed function get called. But when I thought about it, and also in my games, and I also got feedback from other users, you actually never define more than one component listener for one specific component, because you have only one initialization or cleanup logic for a component, and you never have two of those. So having multiple support for multiple listeners was actually useless. That's why I replaced it now to a single function. So this on-add function and on-remove function. And also before, you always had to write this on component added and on component removed. Now you can really distinguish. So if you need an add, you create this on add function. If you want to remove something, you create this on remove function here. And you don't need to specify both if you don't need to. And how does it work? So on add, again, it takes the component type. So for which component we want to run a certain function. What did we have? So we had a sprite. So let's say here we have our foreground sprite. And then we want to write a function. And this function takes over the entity and also the component itself. And it runs within the context of the world itself. Because when you run something in the context of a world, again, we have all those nice entity extension functions, which makes it intuitive to work with it. So here, for example, if we want to get the position component of our entity, then we can still do that in that function block like that. So this would be how to add an add functionality or an add hook function to the foreground sprite in this case. And it's actually the same for the remove function, which we don't need, for example, for the sprite, so we could skip it. So this is one approach, so to directly write it down in the world configuration, which I think is maybe useful for very short things when you don't have a lot of code, then that might make sense. But it's also possible to extract that functionality maybe to your component. This is the approach that I would choose because I think it's more structured and cleaner. So for example, in our sprite, we could have an on sprite add function. There is a type for this function available in Fleks, which is called the ComponentHook. It's for our sprite components, and it's a function. And again, the function takes in this entity and this sprite component argument. And with that, so now we would have this variable here, this on sprite add variable. And now instead of writing the function down here, we can also simply pass it as an argument to the on add function here of the component. So these are these new component hooks instead of the component listeners. Also, if you would need to access any of your injectables in the hook, which might be necessary from time to time. So like before, we had the component listener, which took in this stage. So that is also still possible because we have access to the world, as we can see here. We can then also inject anything that we need. So for example, if you register the stage with the dependency injection part, then we can still access the stage in a hook with the injection, with the inject function. So this is also still possible. Everything is possible as we had it before. So no functionality is gone. Okay, and finally the system. So here again, as mentioned, this is no longer happening with reflection magic and without any magic. So now you simply really add the position system directly and call the constructor here. And as mentioned, so now if we, for whatever reason, we don't want to use the dependency injection mechanism, then instead of writing here inject, we could directly pass in here the stage that we have created somewhere outside of the world and then simply pass it in here. So this should also be more straightforward to use and with less magic than in the background. Okay, and now one more difference. So how does it look like when we now create an entity? So there, instead of this add function and again with this reflection part of the component creation and so on, now simply let's make it clear. So it is our entity, so let's call it E, and here we can now write something like this. So we want to have a position, and there that one takes a vector as an argument, a vector2. So now you simply write plus equal the component and you really create the component directly in here. Same, for example, we have this sprite component where the path was there something with the background. So this is maybe not the background sprite, and here the path was, for example, the sprite PNG from before. So this is how you add now components when we are creating an entity. You don't need to write E here. There is the implicit it, as we know it from Kotlin. You can also use that one. And the benefit of that approach is that actually certain variables, maybe, so the late init variables and the variable in here, they don't longer need to be that because you can directly pass it. So you can, if it makes sense, of course, you can now use a val, so a constant, and we no longer need the late init stuff, which sometimes was necessary with components because, as mentioned before, the components got created by Fleks with reflection in the background, and only afterwards you got inside your block, so you need to modify certain things afterwards. Now this is no longer necessary. Now you can directly pass in the correct values that you want to have because we are really creating the instances down there. So this is now how, for example, an entity creation looks like. And then the configuration, so here it's a little bit different. So instead of calling it configure entity, it's now called configure. And let's configure here our entity. And for example, we want to remove this that component. So there is the minus equal, and there we just want to remove the that component. So here also you see it, we don't longer need this mapper. We directly work with the components, and we simply write here minus equal to remove a component from an entity. And then of course this world update, this is still the same, that would call all the systems and everything. There would be a different approach. So imagine you are working outside of a system, outside of a family and things like that, and you still want to have all these entity extension functions that you have here or that we have inside a hook, so where we can also use that. Then the Kotlin way, which is also in my opinion very intuitive, you say with a world, so in the context of a world, and now for example we can rewrite that a little bit, and or for example we can now write something like this. So from our entity we want to get, for example, the position and do something with x, y, or we want to configure the entity here and then also remove here the that component. Then you don't need to write always world dot something. You can then really write something like this. And now that I see that, maybe it would make sense, because in systems we can write entity configure, which is in my opinion even easier and more intuitive to write than this one here. Maybe I should also allow that actually in that specific context. So let me take note of that. But this is the idea. So in the context of a world, you have then all these entity extension functions available to retrieve components, to update an entity, to remove things. So all of that is there available. And yeah, so these are the changes that are coming with Fleks 2.0. Again, of course, there's always some downsides. The downsides is this boilerplate stuff of the components. But in my opinion, when using live components, live templates, then I think it's acceptable. And as mentioned, it's somehow mandatory because we need, for performance reasons, to optimize everything, these unique IDs per components. And everything else is then, in my opinion, a little bit shorter to write. So for example, the system here is a little bit shorter and also more intuitive to write, because you no longer need these mappers. You work directly with the components. We have some nice extension functions to make certain code pieces readable. And what I did not mention, actually, if you're interested performance-wise, it's a little bit faster than version 1.6 in Fleks. Not a lot, but a little bit faster. So even without using the mappers directly by the users, we still get a slightly more efficient performance here, which is also very, very good. And yeah, that's it. So let me know what you think about that. Maybe you have some feedback, what you would prefer or what you would change. As mentioned, I'm currently working on that, and the plans would be to, in about 2 weeks, release this version 2.0. maybe if everything turns out well, I already upgraded the 2 of my games. So the Mystic Woods game that we did in the YouTube tutorial series, that one I migrated to 2.0. Did not push it yet to GitHub, but that one worked out quite well. And also the Dino Leon game, so where you have this dinosaur and you need to change the color all the time. Also that one I already changed or migrated to 2.0, and those are working quite fine. So I think there should be no major issues with the new version. Okay, that's it. Thanks for listening to me and have a nice day. Bye bye.